If we look at this one, did anyone have a method that they tried with this one? No, the directions for cosine and sine, so this was just simplify. The directions for cosine and sine were only the first page, but cosine and sine is a good method for this one. So what did you do first? She just took a big bite of a cookie, so her mouth is full. Anyone want to help her out and tell me what you would do first? Cosecant, so this would be 1 plus 1 over sine, okay? And then what would the bottom be? Cos over sine, okay? And then what do we have to do with each of these terms? Yeah, each of them have to be multiplied by sine over sine because they have to have a common denominator with the fraction that is next to them that you're trying to add them with. So anytime you have two terms next to each other that you're trying to add and one of them is a fraction, and Tyler, I'm going to have you put your cell phone in prison because you shouldn't have it out. Anytime you're trying to add something with a fraction, they should have a common denominator. So 1, I'm going to go ahead and just rewrite as sine over sine, because anything over itself is 1. And then the cos, I'm going to multiply by sine over sine. Okay. So for the top of this, I have a common denominator of sine. And then what do I have on the top now? I have sine x plus 1. So sine x plus 1. Okay, that's the top. On the bottom, I have a common denominator of sine. And then what do I have on the top? Sine times cosine plus cosine. Okay? And so we just did, we did some typical algebra. Algebra tells us if you add a fraction with something else, you have to have a common denominator. Then we did a little bit of the blue sheet. The blue sheet the blue sheet is what we started with. The blue sheet was what told us we could do some substitutions there. Then we did some typical algebra. At this point, we have a fraction over a fraction, and algebra tells us to do what? Keep it, change it, flip it. So I'm going to keep the first fraction the same, sine x plus 1 over sine x. Change it to a multiplication problem, and then flip the second fraction. Sine cos plus cos. Okay? And algebra tells us what could cancel. The sign on the bottom, the sign on the top, those can cancel. Okay? Now, there's not really good information on the blue sheet that takes sine and cos and translates them into each other. So like a cos can't straight become a sine can't straight become a cos, unless they are being squared. Then you can use the Pythagorean identity, but these ones are not being squared. Do you see that? So that means it's not a blue sheet step. That means we're doing algebra still. That means our next step is algebra. So there is something algebraic that we can do here, and we just have to figure out what it is. So this is about as simple as you can get. Sine x plus 1, you can't add them together. They're not like terms. There's nothing else we can do with it. But over here, is there any possible thing you could think of that maybe we could do? We've actually already done it. It has to do with the cos. You can't add them, though. You can factor them. You're going to take out the cos because you have two terms, each of them have a cos. And so that means that cos is the GCF in this problem. You see that? Two terms, each of them have a cos. So we're going to factor out a GCF of cos. So I'm going to write this as one fraction now. I'm going to rewrite the top, sine x plus 1. On the bottom, I'm going to take out a GCF of cos. And then I'm going to write the leftovers. So for the first term, if you take out a cos, what's left over? Sine x. For the second term, if you take out the cos, what has to be left behind as a placeholder? 1. Does that make sense? That is the hardest step on the problem because it's the easiest to miss. Yeah. So that's the exact same step that you have to do to successfully solve problem number 8. Exact same step, easy to miss, exactly like number 8 was. Yeah. Okay. And then from there, what happens? We cancel. What do we get? 1 over cos, right? The cos is on the bottom. We get 1 over cos. 1 over cos is secant. Oh, I said it was tan. I had a leftover sine. Where did I get the leftover sine from? Oh, I missed this. I missed my common denominator here. Sorry, I was doing bad math. I missed my common denominator when I did it myself. I'll show you guys. I wrote 1 plus sine instead of 1 plus 1 over sine because I was working too fast. So my answer was wrong at the end. So I had an extra sign at the end because mine didn't cancel. So secant is actually the correct answer. Okay. Number 15, what's the first step? Common denominator. You have two fractions you're adding together. They can't be added right now because the denominators are different. You have to have a common denominator. So if this denominator is cos, what am I going to multiply this fraction by? Cos over cos. If this denominator is 1 plus sine, what am I going to multiply this fraction by? 1 plus sine over 1 plus sine. Okay, so our common denominator is 1 plus sine times cos, or you could put the cos in front, it doesn't matter. I realize I wrote that kind of backwards from what is probably comfortable. We have to do 1 plus sine u times 1 plus sine u. That is foiling. When we multiply a binomial times a binomial, we have to FOIL. So we're going to do 1 times 1 is 1. 1 times sine. Sine times 1. Sine. So how many is that? Plus 2 sine. Okay. And then sine times sine. Okay. Okay. And then over here we have cos times cos. Cos squared. So I FOILed. So I did 1 times 1, that's the 1. And then I did 1 times sine and sine times 1. So it was sine plus sine. And then when I did sine times sine, that's where the squared came from. All right. What do you guys see now? Sine squared plus cos squared is 1. Sine squared plus cos squared is 1. Okay? All right, so we've got 1 and 1. Let's combine our like terms. So what do we have? Okay. Now, on the top, we have 2 plus 2 sine u. On the bottom, we have 1 plus sine u, which is the same as 1 plus 1 sine u. So what do you guys think we should do on the top? Not cancel out yet. GCF of 2. We're going to take out 2 from each term, and once we take out 2, then we'll be able to cancel. Okay, so we're going to take out a GCF of 2, and what's left over? 1 plus, so we divided by 2, left with 1, divided by 2, we're left with sine. And you have to be really careful to make sure you're still doing algebra correctly and that your algebra doesn't fall apart because you're doing it in terms of, you know, what feels like words instead of numbers. Yeah. Okay, so I took 2, I divided 2 out of each term. I got 1 plus sine u, and now what do I have? Now they cancel out. So I have 2 divided by cos. What would 1 divided by cos be? It would be secant, right? So this is a 2 that could be moved to the front. You can think of it as 2 in the front and then 1 over cos. That's how you can think of it. And so what's our final answer? 2 secant.
Do I have to write the other one?
You don't have to write this. No. Some students feel really comfortable going from this to this, and some students do not. So I just want to make sure that it makes sense how we were able to get that answer. Okay, number 17 is one we could have different approaches on for sure. So how would you guys like to start number 17?
Take out the
Uh-huh. Okay, so I can definitely see sine over cosine. I can also see, because you got your squareds in there, I can also see using Pythagorean identities. Yeah, you can do tan squared is secant squared minus 1, or you could pull out of the 2, you could pull out 1 plus tan squared and replace it with secant squared. You have a couple different options there. So do you guys want to do the route of changing the problem into sines and cosines, or do you want to do the route of using Pythagorean identities? Pythagorean identities? This is what we want to do? Okay. So we have 2 options with the Pythagorean identities. Do we want to, from the 2, pull out a 1 plus tan squared and replace it with secant squared? Or do we want to ignore the 2 and say that the tan squared by itself is secant squared minus 1? Okay, so we'll say the tan squared by itself is secant squared minus 1. So the benefit of using the Pythagorean identities the way that we are is that we are going to still have just one fraction. If you did sines and cosines, you would have a fraction on top and a fraction on bottom. So this is kind of the benefit of not doing that. But ultimately, remember, you're going to get the same answer in the long run. So there's not a wrong way to do this problem as long as you were following the rules. So tan squared, we're going to replace with secant squared minus 1. That's the blue sheet. The blue sheet tells us we can do that. Divided by secant squared with a minus 1 on the end. Okay? All right, what should we do next?
cancel out.
Cancel out what? Can we cancel these out?
No.
We can't cancel those out because this is plus secant squared, and plus and divide don't cancel. So we can't cancel those out. We can combine like terms though. A positive 2 and a negative 1 gives you 1. Okay, so we have secant squared plus 1 over secant squared with a minus 1 on the end, okay? We've done something like this before, we just have to remember it. So keep, change, flip is typically going to be used if you have fraction over fraction. So what I was thinking of is you could split this into two fractions, which is that what you were saying? Two fractions with the same denominator? What were you saying? Oh, you were saying... Oh, that's a good thought. Okay, so what I was thinking, because Carly and I were having two different thoughts. I was thinking make this one fraction, make this a second fraction, and let them have just split them as two different fractions, which you can do. You can split them apart. Carly was thinking take this -1 over here and give it a common denominator, so you just have one big fraction, all with common denominators. And our two methods are about the same level of difficulty. So would you guys rather split this into three different pieces, one piece, two piece, third piece? So this would be two different pieces, two different fractions, or do you guys want to take this one and give it a common denominator so they can all be under one fraction? Common denominator? Okay, so the one, what would we need to fix the one to be so that it could be combined? Okay, so we're going to multiply, we're going to do secant squared over secant squared. And so now we have one big fraction, secant squared on the bottom. And what's on the top? Secant squared plus 1 minus secant squared. Okay, and then what happens? The secant squareds cancel out, and what do you end up with? 1 over secant squared, which is cos squared. Okay, I'm going to show you guys the way I did it because it is it works out very similarly. So when I did this problem, here I am at the place that we just were. I took this fraction and I split it into two fractions. So I did secant squared over secant squared plus 1 over secant squared. Does that make sense? I split it into two fractions. Yeah. Yeah, one second. So if you do it this way, secant squared over secant squared is just 1. And then you get the 1 minus 1, they cancel, and then you get your cos squared. So it's the same level of difficulty as yours was. Let me see another way. So you did, in the beginning, you split the two fractions apart, and then you did the sine cosine version. Yeah, that makes sense. So 2 over secant squared, this is getting the cos over here, and then sine over cos, and then you did keep it, change it, flip it. And then turned your sine into 1 minus cos squared. And then got one of your coses to cancel. Yeah, so you guys can see if you do it with putting it in terms of sines and coses, you can still do the problem, but do you see how it was a little bit more difficult? Like we had the keep it, change it, flip it over here, but you also end up with multiple cos squareds, which makes it a little more difficult. So sometimes it's still possible to do it in sines and coses, but sometimes it makes it more difficult to do so. Yeah. All right, let's do number 19. That was the last one we wanted to do. Okay, number 19, I mentioned earlier in the assignment, where was it? Number 10. Number 10 had this negative x in there, and I said on the blue sheet that when you guys worked yesterday, we were going to use these, but not very much. Number 19 is the other one that uses these, and they're just straight substitutions. And we cover even and odd identities in pre-calc. and they'll make more sense there, but it's not really in the scope of this particular class. We don't really cover them in Math 4. So you're going to need those on the blue sheet to do number 19. So tan is just tan. Cos of negative theta is actually just cos, so we'll switch that one out. So we've got tan theta for tan theta, cos theta for cos of negative theta, and then tan of negative theta is just negative tan theta. And those were on your blue sheet. So that was just straight substitutions. And then that makes that a really easy problem after you know to substitute those. So tan and negative tan cancel. You just get cos. Okay. How are you guys feeling about the simplifying problems? Did they start to get easier? Now, what I've noticed in previous years is it's not the blue sheet stuff that's the hard part, it's the algebra. Is that what you guys are noticing too? Are you running into algebra stuff where you're like, okay, note to self, don't do that. That's not algebra? Yeah? Okay. So we're going to switch over. It's going to be very similar to simplifying, but we're going to switch over to something where it feels like you're solving an equation, kind of, but they're actually called trig proofs. So we're going to take these, we're going to write our names on them, we're going to turn them in, and then we're going to come back and get some paper out to take notes on trig proofs. Now, after today, we have 2 days until spring break. Is everybody planning on being here the next 2 days? Is anybody not going to be here on Thursday? Because I'm trying to figure out. We are getting to the point where we should probably have a quiz on this stuff, because it's either quiz right before spring break or quiz right after spring break, and obviously right before spring break is better than right after. So I tentatively feel like Thursday might be the best day for the quiz to give you guys more time to practice. But if a lot of people are going to be gone on Thursday, then tomorrow is the better time for the quiz. So do we know of anybody else who's going to be gone on Thursday? We're planning on being here? Huh? Okay. No, you'll be able to use your blue sheet. You'll have the blue sheet. You'll have the blue sheet. I'll give you the blue sheet on the quiz and the test. I might give you a new blue sheet, or like print out, like copy paste the stuff of the blue sheet onto the test. Yeah. Okay. So I think that I'm gonna give you guys a quiz on Thursday. I think that's gonna be my plan. And then as far as spring break goes, my intention is not to give homework. I'm not really a homework over a break kind of person. So so you guys should be good as far as that goes. No homework, no project, no nothing. Just be yourselves, come back. Okay. All right, so here's example 1. Do you guys know of any other tests you're having? Is Thursday going to be a heavy test day? Okay. 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 All right. So here is the first proof we're going to do. And the proofs are very similar to the simplifying that we just did, but the answers are not as short necessarily. But like yesterday when I had the answers up and I told you to take a picture of them so you kind of knew what the answers were ahead of time, that's exactly what a proof is. It's you know what the answer is and you're just trying to get there. So here is the first proof we're going to do. We've got cos theta times secant theta minus cos theta equals sine squared theta. And actually, I'm not going to call this the method because it's not really a method, but the strategy that is best because in theory, when you do a proof, you could work with the left side and you could say, okay, I'm going to manipulate the left side until I get it to equal the right side. Or you could work with the right side and manipulate the right side until you can get it to equal the left side. In theory, both of them work. But this strategy is work with the more complicated side. So we're gonna go through, we're gonna do this proof, and then I'm gonna explain to you what I meant by this strategy. So we're going to be working with the left side because the left side looks more complicated than the right because it's got more stuff going on. It's got parentheses, it's got a term here, 2 terms there, it's just got more going on. So I'm gonna start by rewriting the problem. Cos theta times secant theta minus cos theta equals sine squared theta. So sine squared theta is the answer that we are trying to get to. That is our goal, okay? So if we go back over here, what do you guys think we should do to start this problem? Maybe before distributing. I would take the secant and make it what? 1 over cos. Okay, I'm going to leave this as cos. I'm going to take the secant. I'm going to make that 1 over cos minus cos. Okay? And you can keep saying, like, oh, this equals sine squared, or if you want to just say, like, the same thing. Some people use, like, those little, that little quote just to say, like, yeah, the above thing, so I don't have to keep rewriting it. Now, if we have a fraction and something else next to it, what are we supposed to do? Common denominator. So I'm going to go ahead and do that. So if I've got cos, this is cos over 1. I'm going to take this and I'm going to multiply by cos over cos so that I get that common denominator. And so at this point, inside my parentheses, I have a common denominator of cos. And then what do I have on the top? 1 minus cos squared. Okay. I still have the cos outside. And then here I'm just going to write, yeah, it still equals that sine squared. I just don't feel like writing sine squared again. Okay. Now, what do you guys see that we could do? Say it again. So we don't need a common denominator if we're multiplying. Should we distribute? 1 minus cos squared is sine squared. So as soon as I start seeing a squared in the problem, I want to look at my blue sheet and look at the Pythagorean identities. As soon as I see a squared in the problem, I want to look at my Pythagorean identities. And the reason for that is because I know my goal is sine squared. And I know that cos squared and sine squared have a relationship. So if I'm trying to cheat, if I'm like looking at the teacher's answer key and I know the answer key has a sine squared in it, I'm going to try to get to that answer key answer as soon as I can. Does that make sense? Like, that's how it works when you're trying to get the answer. So 1 minus cos squared, the blue sheet tells me that 1 minus cos squared is sine squared. Okay, so let's switch out the 1 minus cos squared for sine squared. Okay, so my goal is to only have sine squared, though. That's all I want. I don't want anything else. So the coses, they cancel out, okay? Because technically this is a cos over 1. This is a cos on the top. This is a cos on the bottom. So these cancel. Okay? So all I have left is sine squared over here. And on the right, I've had sine squared the whole time. So I have just proved that sine squared equals sine squared. Does that make sense? Okay. Now, the strategy that we used is we worked with the more complicated side. The reason we use that strategy is because it is much easier to take something that is complicated and simplify it, make it less and less and less than it is to take something that is simple and introduce the exact right things to make it the right amount of complicated. Does that make sense? How in the world was I going to know that sine squared needed to be over cos? And that sine squared needed to become 1 minus cos squared, and that then I needed to split those apart and get rid of the denominator right here, and that this needed to become a secant? There is no way I was going to be able to see that from sine squared. Does that make sense? But from this side, all I had to do is think of algebra steps. Get a common denominator. Then I had to, at one point, recognize 1 minus cos squared was a Pythagorean identity. At one point, I had to recognize the blue sheet. But after that, it was just me doing regular algebra. So it's much easier to take something complicated and simplify it than it is to take something that's simple and make it complicated. Does that make sense? So whenever you look at the proof to start with, whatever side is more complicated, that is the side that you work with. Does that make sense? Okay, let's try another one. So for this one, we're going to do example 2. We're going to do 2 times tan x times secant x equals 1 over 1 minus sine x minus 1 over 1 plus sine x. Now, the strategies that we learned on the simplifying, those strategies are still true. So the strategy that we had of like take stuff and turn it into sine and cosine, that's still a good strategy. It doesn't work every time. Like sometimes it will make the problem more difficult, or it will make the problem take longer. There could have been an easier method. It'll still get you there in the long run, but it's not the easiest method. The other strategy we talked about was if you have fractions, get a common denominator. We've seen that may not always be the first step, but almost always in a problem with fractions, you're going to have to do that. So this strategy is if you have 2 terms, choose to work with the side with more terms. And this is the same idea as working with the more complicated side. So the left side here, this is all one term because there's no pluses or minuses. So that's considered to be one term. This side over here has 2 fractions with a minus in between. So this side right here is 2 terms. So I'm going to choose the side that has 2 terms. So it's a great question. You are not supposed to do both sides.
So you couldn't try to simplify.
No. So one of the sides you do not touch. You leave it the same the whole way through. The other side you manipulate completely until you get it to match that side. That's a really good question. Okay, so we're going to leave the left side the way that it is, and then the right side is the side that we're going to manipulate. So I'm going to write the left side 2 tan x secant x, and then the right side 1 over 1 minus sine x minus 1 over 1 plus sine x. Okay? And so what is my first step? Get a common denominator, right? When you have two fractions, you should get a common denominator. So for the first fraction, what should I multiply by on the top and the bottom? 1 plus sine x. 1 plus sine x on the top, 1 plus sine x on the bottom. Okay? For the second fraction, what should I multiply? 1 minus sine x on the top, 1 minus sine x on the bottom. Okay, so I'm going to just say, okay, the right side equals, our common denominator is 1 plus sine x, 1 minus sine x. I'm going to leave these. I'm going to leave them unfoiled because I've noticed that in fractions things cancel sometimes, and so it would be nice to see them in the factored form just in case they end up canceling with something. Okay. So for the first fraction, I've got 1 plus sine, and then we have to be careful to distribute the negative. And so when I distribute the negative, what do I get? Minus 1 plus sine. Okay. Okay, so what do we see? Okay. Wait. What happens with the ones? The ones cancel. And then what happens with the signs? They combine, and what do you get? Wait, do you get sine squared if you add two signs? Okay, so you just get 2 sine. Okay, I'm already seeing part of the left side. Are you guys seeing it? What part are you seeing? The 2. We can see the 2. So we know where the 2 came from. There's the 2. Okay, so I've got 2 sine x, and then I've got 1 plus sine x, 1 minus sine x. Okay. So now we have to remember that this needs to become 2 tan x secant x. Now, is the top going to cancel with the bottom over here? No, it's not. So since the top is not going to cancel with the bottom, we know that for sure. We have to FOIL the bottom. Yeah, the bottom is not going to do anything until we FOIL it. So we left it factored just in case something canceled. Nothing canceled. Let's go ahead and FOIL it. So I'm going to leave 2 sine x on the top. If we FOIL the bottom, we get 1 times 1 is 1. 1 times negative sine, sine x times 1, positive sine. So we have a negative sign and a positive sign. That they just cancel out, right? Positive sign and a negative sign cancel out. And then we have a positive sign times a negative sign. Negative sine squared. Does anything cancel out there? So we've got a squared. What does it turn into? 1 minus 1 minus sine squared is cos squared. Okay. So we've got a 2 sine x on top. and we've got a cos squared on the bottom. And remember what our final answer is supposed to be. So I'm going to write this, and you have to be able to see it. This is what the answer key says. The answer key says this. And you have to be able to see how this can get you to that. Sine over cos by itself is tan. So, okay, so I'm gonna write this in a very specific way so you guys can see it. I'm gonna put the 2 first. I'm gonna put the sine over one of the coses, and then I still have another cos. So I just rewrote the same answer, but I spread it out. Do you guys see it now? So 2 sine x on the top, cos squared on the bottom. Do you see how it matches the answer perfectly? So this is 2. What is this? Tan. What is this? Secant. 1 over cos is secant. See how it matches? So when the algebra runs out, when things aren't canceling, we start going to the blue sheet. When the algebra runs out and things don't cancel anymore, we go to the blue sheet. That must be what's happening then. They get easier to recognize the more you do them. And that's part of why this is beneficial to be working together on this, because one person may not recognize it, but somebody else might. Okay? Would I give you this as a quiz question today? No, probably not. Because you might not recognize this now, but once you practice more, then you're going to start to recognize this. This would be really fair as like a pre-calc quiz question. Once you've seen it more, once your brain is sharper with it. Yeah. All right. So we're going to say 2. At the very end, once you have finished the proof, you always want to get to the point where you say the left side and the right side are the same, 2 tan x secant x, and this is just good proofs, equals 2 tan x secant x, where you get the left side and the right side equal each other. That shows that you know that you proved what the goal was to be proved. No. They're always going to work. Mm-hmm. Okay. Let's do, what is it? Okay, we're going to do one more. So 1 plus cos theta over cos theta equals tan squared theta over secant theta minus 1. Now, based off the number of terms, these look like they're both the same level of difficulty, right? But which one feels more uncomfortable? The right side. Like, that's everyone's gut, right? The right side feels more uncomfortable because cos is more in our comfort zone. And usually our first step is to get things in cosine and sine. That's like our first, yeah. So almost everyone would immediately go to the right. So that's what we're going to do. We're going to go to the right. So this is the side we're going to keep the same the whole time. The left side is what we're going to keep the same the whole time. And the right side is what we're going to work with. So anyone have any ideas? Yeah. Okay, so if you look at tan squared, it's a Pythagorean identity, and tan squared can become secant squared minus 1. So we're going to take the tan squared out, And we're going to write secant squared minus 1 over secant minus 1. Do they cancel out? Now this is just normal, but since this is squared, this is difference of squares. This is like x squared minus 1. Not split it in half. Not two fractions. So you can only split fractions if the denominator is one piece. So you can't like split it like this as two fractions. You can factor it. So if x squared minus 1 is what you were factoring, then what would your two factors be? X plus 1, x minus 1. If you were factoring and x squared minus 1 is what you were factoring, you would have x plus 1, x minus 1. So if this is the same thing as secant squared minus 1, you're close. It's x squared minus 1 is x plus 1, x minus 1. Secant plus 1, secant minus 1. Does that make sense? Okay. So since we can factor it, we've got secant minus 1, secant plus 1. So we've got factors that cancel. Okay, and this whole time we've got our left side. This is our answer key. And now, how do we get from this to our answer key? Okay. So secant is 1 over cos. And then for our 1, we want this to have a common denominator with 1 over cos. So we're going to write this as cos over cos. And then we can say, okay, we got our common denominator. And our numerator is 1 plus cos. Aren't these kind of crazy? Okay. I'm going to start you guys off on ones that are not near as crazy. We're going to start you slow. So I scanned the pages of a math textbook for you. So you guys are going to do your assignment on notebook paper. And we're just going to start at the beginning and we'll see how far we get today. So we're going to start at problem 21.